Hello everybody. Today we're going to be working on verifying inverses. In AA6a-2, we did finding inverses algebraically, and I gave you some notes on verifying them with just putting in a number. And so we're going to do that for the warm-up, and then I'm going to show you a different method for it, and we're going to discuss a couple of things. Reminders about function notation, things like that. So to find the inverse of f of x equals x squared minus 3, first you need to remember that f of x is the same thing, or essentially the same thing as y. And so the first thing that you're going to do is take your x and your y and you're going to switch them. So this equation is going to be x equals y squared minus 3. And then the next thing you need to do is solve for y. So you need to get y by itself. So the first thing we're going to get rid of is this 3 here, and we're going to do that by doing the inverse operation. So subtracting 3, the inverse would be to add 3. And since x and 3 are not like terms, we're just going to write that as x plus 3 equals y squared. And then to get rid of that squared, we need to square root both sides. And whenever we're square rooting to solve, that's always a plus or minus. So we've got y equals plus or minus the square root of x plus 3. Finally, we want to write that in function notation. So f to the negative 1 of x, or the inverse of the function. Whenever you have a square root, you want to be particularly careful about where your sign ends. I took the square root of the entire side, so this is the square root of x plus 3, the whole thing. You want to be particularly careful about that when you're dealing with any fractions in your inverses and making sure that it's all very obvious what is being square rooted. So now what we're going to do is verify according to what we did last time. So to verify, we're just going to pick an x value. So I'm going to say x equals 2. And that's sometimes you want to pick an x value that's in the domain of your function. So if you have square roots or if you have fractions, you have to be careful that you don't end up with a negative under the square root, or that you don't end up with 0 in your denominator, or as your denominator. Otherwise, you can pick pretty much anything. So I'm going to take that original function, so we're going up here, and I'm going to do f of 2 equals 2 squared minus 3. So all I did here, just to make sure we're clear, is instead of f of x, I'm going to do f of 2. Plug in 2 for the x, and then I'm just going to evaluate. So this 2 squared is 4 minus 3. 4 minus 3 gives us, not 3, gives us 1. Sorry. And then I'm going to take that, and I'm going to put it into my inverse function. So this is going to go in here. And I don't need to worry about the plus or minus for the verification piece. I'm just going to use the plus. So f of 1 equals the square root of 1 plus 3, which equals the square root of 4, which is equal to 2. Now, if I've done this correctly, if my inverse is correct and I've done all my math correct, this number that I end with and this number that I decided to put into my original in the first place should be the same number. And that's how you verify. And that would be for proficiency level, just verifying by using a number. You can plug into your inverse. Sorry, that's not your inverse. That's your original. You can plug into your original first, which is what I did, or you can plug into your inverse first and then plug the outcome into the original. Either way is fine as long as you go through that entire process. Okay. So a couple reviews about function notation. So what we did in class was I had the group discuss this and then we shared out. First off, f of x equals 10. That's how you say that. And this is f of 10. Keep in mind, this is not f times 10. This is not f times x. This is f of x. So a function of x equals 10, and then this is a function of 10. So normally this would be accompanied by an actual equation like f of x equals 2x plus 5 or something like that. What f of x equals 10 means is that you are being asked to find or solve for x when y equals 10. Or rather, when f of x equals 10. But since they're essentially the same thing, and that's probably what you're more familiar with, I'm going to go ahead and write it like that. On the other hand, if I have f of 10, this is telling me to find, and in other words, evaluate to get y. When you know that x equals 10. So in this case, sorry, I'm not pointing at anything. So in this case, we have an x there because we don't know what x is, so we have to solve for it. But we'd solve for it by using our inverse operations. In this case, there's no x there. That means we know that x is 10, and we just have to plug that in to find y. So just wanted to be totally clear on. So to practice that, we're going to use our function from the warm-up. So f of x equals x squared plus 3. So f of 6 is going to be 6 squared. And I'm going to use parentheses just for good measure. So f of 6 equals 36 minus 3, which equals 33. So that's my answer. I should just have a number, or f of 6 equals that. On the second one, f of x equals 13. 13 is going to go in there for this entire thing. So this is 13 equals x squared minus 3. I'm going to add 3 to both sides. So 16 equals x squared. I am going to square root both sides and put that plus or minus. So over on this side, I've got x equals, I'm going to go ahead and erasing that to solve that. Sorry. So I've got positive and negative 4 for my answer. And I kind of talked about this in the warm-up, and I've talked about it before, but just to reiterate, if I have x squared equals 16, 4 squared is equal to 16, and negative 4 squared is also equal to 16. So that's why I have this plus or minus there. However, if I have something that is just, if you were to just ask me what the square root of 16 is, it's just 4. The plus or minus part comes into play when we're solving because of, well, that's not what I meant to do. When we're solving, because x squared indicates that it can be both a positive and negative squared is going to give you a positive number. So that's where those two answers come from. Okay, so the next thing I want to talk about is composite functions, which you may or may not be familiar with. I have two different functions here. F of x equals x squared minus 3, still the one from the warm-up, and then g of x equals negative 2x plus 10. I have the two different letters, the f and the g, only to signify that they're two different equations. So what I have here in this composite function is the function of a function of 3, a different function of 3. So g of 3 is where I'm going to start. So I'm going to take this and I'm going to find g of 3. So g of 3 equals negative 2 times 3 plus 10. And I'm going to evaluate. Negative 6 plus 10 equals a positive 4. So now what I want, because the value of g of 3 equals 4, is I'm going to find f of 4. So my f function up here is x squared minus 3, so that's going to be 4 squared minus 3, which equals 16 minus 3, which equals 13. So f of g of 3 has a value of 13. So that's a composite function. And that's kind of what we're going to be using for verifying inverses for a highly proficient, as opposed to just proficiency level. So for proficiency level, we plug in a number, whatever comes out of that, we plug it into our inverse, and that should be the number that we started with. Verifying without picking a value for x means I'm going to take my entire inverse and plug it in for x, and then I'm going to evaluate. Now, so what I'm really finding is the function of the inverse function. And I'm not entirely sure I'm saying that right. But where normally I'd have x squared minus 3, I'm going to leave myself some space there. I'm going to take out that x, and I'm going to move the squared over. And then I'm going to put in my inverse function. So I'm going to put in the square root of x minus 3. And for good measure, I would put that in parentheses. It's not always necessary, but it's a good habit to be in. So this part, if you were not in class and you didn't hear me say it, this is really, really important that you show all your steps, because these are always going to come out the same way. And if you don't show your steps, I don't know if you actually did it or if you just guessed. So right here, we have a square root of x minus 3 being squared. The square and the square root are inverse properties, so they are going to, in essence, cancel each other out. So what I'm left with is x minus 3, and then I'm going to drop down. Oh, no, that should be plus. Hopefully you were not too confused by that early on. And I'm going to drop down the minus 3, so I apologize for that error. My next step in this evaluative process is that 3 minus 3 is 0, so I'm not going to drop that down, and I'm left with x. That right there tells me that I'm good to go. If you put the inverse function into the original, or you put the original into the inverse, so let's try that one first, or not first. Let's try that one. Oh, this is super helpful. All right, let's undo all of that. There we go. I'll just scooch this over a little bit. So let's try that again. So if I take the inverse function of my f of x, so my inverse is the square root of x plus 3, and I left my space for x there. Now I'm going to take the x squared minus 3, and I'm going to put it in for x. So I'm going to erase that, put in x squared minus 3, and then I'm going to evaluate from there. So the plus 3 and the minus 3, or the negative 3 and the positive 3, add out to 0, so I'm left with the square root of x squared. The square root and the squared are inverse operations, and so what I'm left with is x. So again, ending up with x means that you're good to go. And so that's always going to happen, which is why it's so important in terms of your test that you are showing me all the steps in between. I saw a lot of people in class, like, with their first step, just going, that crosses out, that crosses out, that crosses out, and that crosses out, so it all equals x. That's not sufficient, because there's just no real way for me to grade that unless I actually see all the steps that you took. So one at a time, show your steps if you want the highly proficient credit. And that is it for verifying your inverse. It's one of those things that takes some practice, and once you get it down, you're good to go. So you have next class, you will have a group test / review, and the class after that, we're going to take the second round of Unit 5, Part B, and then the first 3 topics of Unit 6. So have a great day.